Hello and thank you for joining today's webinar. I'm Jordan Sloop, your host from Kentik Marketing. Our topic for today is how to monitor Kubernetes using synthetic testing. Our presenters are Kentik's Director of Product Management, Anil Murty, and open source developer, Evan Hazlett. So in today's webinar, Anil and Evan will demonstrate how to integrate Kentik Synthetics with your Kubernetes deployments and how that enables you to proactively monitor your network without sacrificing reliability. So during the webinar, if you have any questions, feel free to enter them in the Zoom chat and we will answer as many as we can in the Q&A session at the end of the presentation. So with that, I'll pass it over to you, Anil.
Thank you, Jordan. Hey, everyone, and thank you for joining us. In the interest of time, I'm going to jump right in. For folks that are joining us for the first time, I'm going to do a quick intro of Kentik. So Kentik is the network observability company. And we are fortunate to count among our customer base some of the biggest brands in the world that you can see reflected, a few of those at the bottom of the slide. So when we ask our customers the reasons for why they choose us for their monitoring needs, one of the most common responses we get is that Kentik enables them to increase the uptime of their services and their networks, in some cases by as much as 25%. And so the way Kentik does this is by essentially ingesting trillions of records of data about their networks as well as the services each day, and then providing certain set of visualizations as well as other things within our platform that enable all of these customers to get visibility into their networks. So the way all this works is essentially through what we call our network observability cloud. And there's basically three pieces to our solution or to our platform. On the left side are all the sources of telemetry that we can ingest within our or into our platform. And these might consist of network telemetry coming from routers and switches and other network devices that you own and operate on your own. Or there might be network telemetry that is coming from virtual devices, like the kind that you would own or operate within public cloud regions, for example. And then, of course, you can also enrich all of this data with your own business context before you send it into Kentik's SaaS platform. And so once all this data ends up within Kentik's SaaS platform, the SaaS platform exposes a set of dashboards, a set of query engines, as well as various analytics within the platform for you to be able to ask any questions about your networks. So the way all this gets surfaced up within our platform is through a set of products. And these range from our core networking product, which is all about looking at your core networks and all of the data that's flowing between them, anything that you're running within the cloud, anything on your edge, all of your edge devices, doing things like DDoS protection, as well as looking at service provider analytics if you're a service provider and doing peering and transit routes, for example, and then of course synthetics as well. So for the focus of this presentation today, we're going to focus specifically on the synthetic monitoring product within our platform. And to tell you a little bit about that, the idea with synthetics essentially is it's all about trying to monitor things proactively as opposed to reactively. And so unlike reactive monitoring, where you're looking at data that's just passively flowing across your networks, with synthetics, you're actually actively generating data. And so the way this data generation happens is through the concept of agents. And so these agents are little tiny pieces of software that could be running in various parts of the world in various types of infrastructure. So there might be agents that are deployed within your own data center. There might be agents that are deployed within your cloud regions. And each of these agents is capable of running tests across the different layers of the network stack. So essentially, when it comes to these agents, there are two broad types of agents. There are agents that Kentik hosts and provides out of the box, and these are what we refer to as global agents. And there's well over 230 of these now, and they're constantly growing as well. And then there is the concept of a private agent, which is Kentik basically taking that same exact software image and providing it to you as a customer to be able to install on any sort of infrastructure that you like. And so, there's a bunch of things that we do that are very unique to our platform, which include combining, real flow traffic as well as synthetic monitoring together and enabling something called autonomous testing. We also happen to have the biggest and the most richest BGP data set, which gives you a lot more visualization as well as insights into, the health of your networks. To dig sort of one level deeper and talk about the types of tests and the agents that we support, as I mentioned, there's basically two types of agents. There's the public agents that we host and provide out of the box. These public agents are, located in a combination of cloud provider regions. So we have support, we have agents that are located in all the AWS regions, all the Azure regions, as well as GCP and Ali Cloud. And then we also have agents located in transit provider networks. And then lastly, we have agents located in broadband ISPs. So if you have a use case where you want to look at performance from an end user perspective, you would probably be interested in the broadband agents. And then the private agents, as I mentioned, it's the exact same binary provided to you to deploy on your own infrastructure. And this is typically right now it's a Linux-based binary. We provide it as a Debian package, an RPM package, and a Docker container, and it's extremely lightweight. So what that means is you can run it, of course, on your own infrastructure as well as within public clouds, but you can also run it on something as lightweight as a Raspberry Pi. And then on the left side are the various types of tests that we offer, and these span the various layers of the network stack, going from the network layer with IP tests and host name tests into the routing layer, talking about BGP monitoring, things like hijack detection, prefix reachability tracking, so on and so forth, up one layer into the DNS layer, and then up finally to the web layer where we do things like page loads and transactions. So that's just a quick overview of the types and tests and agents. Now, as important as it is to be able to run these tests and get the data from them, it's equally important to be able to tune these tests to the kinds of things that you want to be doing, right? So in terms of workflow features, there's kind of 4 buckets of workflow features that we offer. First and foremost is the test tuning and customization. So, if you're running a certain type of application that only cares about, latency and packet loss and does not care about jitter, you can sort of dial up and dial that down with thresholds within the tests. You can choose what type of protocols you want to be testing. So if you're a voice type of application and you want to be testing UDP protocols, you can configure the agents in the test to be sending UDP traffic as opposed to ICMP or TCP. So there's various options in terms of frequencies, in terms of probe counts, so on and so forth. Alerts and notifications, we've got in-app alerts as well as notifications to the most common notification channels, and then sharing and exporting. So if you want to be able to pull all this data using an API, that's supported. If you want to be able to push it into some sort of third-party data lakes or other network monitoring systems, you can do that using a Firehose product. And then there's link sharing, which is essentially you being able to share a link with somebody that can look at the test results without having to authenticate and log into Kentik's platform. And then last, and which is kind of part of our presentation today, is automating all of this. So obviously, Kentik exposes an API that lets you, be able to create these tests as well as read the results. But then in addition to providing that API, we also provide a Terraform provider as well as a Kubernetes operator. And so for today's presentation, we're going to focus specifically on that Kubernetes operator, and we're going to talk about how you can leverage our open source Kubernetes operator to not only deploy and scale the agents within Kubernetes clusters, but then also enable automation of tests that are going to be checking, the health of the applications and services that are running on top of the Kubernetes infrastructure. Before we dig into all of that, we've got a quick question for you. If you wouldn't mind taking a poll that's going to flash up on your screen right now, we're really curious as to where you are in terms of your journey with Kubernetes today. Thank you all for taking that poll. It definitely helps us. So it seems like we've got a mix of people that are either deploying and running Kubernetes today or are thinking about doing it. So I won't spend a ton of time talking about what Kubernetes is because most people are familiar with it. But obviously, the idea with Kubernetes is it scales really well and it does so horizontally. And it's probably one of the most widely adopted open source projects out there, which is a huge benefit as well. And it has a lot of mature features which make it attractive as a solution when you're thinking about orchestrating workloads, right? The challenge, of course, like with anything that abstracts a lot of complexity, is that it reduces visibility. So what that means is if you have an issue that happens within your infrastructure that Kubernetes is running on top of, or within the services that Kubernetes is helping you scale, it's really hard now for you to be able to know where the issue is and sort of what layer it might be in, right? And so this is where we think it's really important for a monitoring solution to be able to scale with Kubernetes as Kubernetes scales, as well as scales your applications that are and your services that are running on top of Kubernetes. And that's kind of the focus of the operator that we're going to talk about. So to tell you a little bit about the idea of an operator within Kubernetes, as well as specifically our operator, I'm going to invite Evan to talk about these.
Thanks, Anil. Yeah, so most of you are running or at least looking to run Kubernetes, so you might be familiar with this. But for those that don't or haven't dug into the internals, don't worry. We're just going to give some kind of background on what operators are so that we can relate to them and understand how ours operates. So in Kubernetes, an operator allows you to extend the Kubernetes API to enable custom application and domain-specific functionality. So what this means is you can take existing Kubernetes capabilities such as the controller pattern, resources, objects, and normal kube operations, and you can use those in your own domain logic. You do this by creating custom resources through custom resource definitions, or CRDs, and that provides your actual application data. So in the case of Odyssey, where we'll have like an HTTP request, those might have an endpoint as well as a port and a target and timeouts, et cetera. That logic is what's created into the CRD. And the way that the operator works is it tracks that resource as well as the cluster state and then performs the reconciliation once it sees the changes. For our specific Odyssey operator, Odyssey is our open source operator. It's complete open source. We invite you to contribute and take a look at it. It provides the CRDs to define those tests. So for example, an HTTP GET, a ping, trace, etc. And this isn't unique to Odyssey, but rather the operator pattern in Kubernetes in general. But it's nice because it integrates into existing Kubernetes workflows. So if you have a team that's used to using Kubernetes through either the tooling or even the API, you can use all of that same tooling, including all of your API, even third-party API tools, to manage all of those resources. So you could use those to create our own CRD, or to manage our own CRDs. As far as Odyssey itself, it's pretty simple. It automates basically all of your synthetic test management. So it'll do things like automatically registering agents and deregistering, cleaning up, as well as managing the test lifecycle to create tests, apply them to the agents, actually run it, get results, and then clean up after that. A primary design objective that we had is to not only enable the application level testing, but also Kubernetes itself. Because as Anil said, when you abstract those away, you reduce visibility. So with Odyssey, we wanted to make it easy for people to use their existing workflows to manage and monitor Kubernetes as well.
Awesome. Thank you for that introduction. So what we're going to do next is we're going to do a quick demo, and we'll basically do two parts to this demo. First, I'll give you a general overview of synthetics and, in terms of agents and tests and how you can set those up. And then I'll pass things over to Evan to show us how you can then automate them using Odyssey. So I'm going to go here into this next tab, and what you're looking at is the Kentik UI. So as I mentioned before, Kentik has a bunch of different products. Synthetics happens to be one of them. And then within Synthetics, there's basically the idea of agents, which are things that will run the test for you. There's a test control center where you can go and set up tests, as well as look at existing tests. And then there's the performance dashboard that shows you sort of the overall health of all the tests that are running from a synthetic standpoint. So to just talk about a little bit about the agents, as I mentioned, broadly, there are two types of agents. There are agents that we host and provide out of the box as a service. So on the map here, you can see every dot that is a Kentik logo. That represents one or more synthetic agents that Kentik has deployed in that particular geographic location. And these are located in various networks, which are a combination of sort of cloud, public cloud, non-public cloud, as well as broadband ISPs. And each of these potentially has, 5 or 10 or more agents in that particular ASN. And then what we do is we give you that exact same binary that's running under these global agents in something called a private agent. And so you can deploy these on literally any type of infrastructure that you're running, as long as there's a Linux OS running on it. So to deploy one of these is extremely easy. If you want to do it manually, you can just go here, pick the kind of package that you want. So let's say Docker is your choice, you pick on that, and there's literally just 2 commands to run. One to pull the Docker image and click to run it, and that's it. Your agent's up and running, it reports into the portal, and so on and so forth. So once you have these agents set up and you know where you want to be testing from, the next thing to do is to set up a test. And so when it comes to that, you go into this add test page here, and it shows you basically the types of tests that are offered within the system. They go from the network layer into the routing layer, all the way to the web layer and DNS as well. To take an example of one of the tests that you can set up here, I'm going to pick this HTTPS or API test. And the idea here is if you have an HTTP endpoint, which might be, for example, a web page or a website that you're hosting, or it could also be a API endpoint if you're running services within Kubernetes, for example. So what you would do there is you would go and say, do get or a put or a post or patch, any type of HTTP method. Go ahead and enter the specific, URL endpoint that you want to be hitting. So in this case, it's, for example, a DynamoDB endpoint within Amazon. And then once you do that, you have the option of enabling ping and trace out to the host as well. So if you turn on this option, what Kentik will do is essentially not only do a HTTP GET on this, but also once Kentik resolves the domain to the specific IP address, we'll go ahead and set up ping and trace route towards that specific IP as well, so that not only are you getting HTTP layer metrics, you're also getting network layer metrics, and are able to look at an actual path of the packets flowing from the agent, which could be in any location in the world, to that specific Amazon instance. So once you do that, the next thing to do here is to pick the agents that you want to test from. So this would kind of be dependent on where you want to be testing from in terms of locations. This could be a combination of agents running within your own data centers, for example, private agents, or they could be any of the global locations. So you just go ahead and pick any of these that you want, hit save. And then once you do this, we're going to go ahead and create one test each from each of these agents to that endpoint and show you a bunch of results on that. Optionally, you can configure custom headers, parameters that get sent along with the HTTP request. And if it happens to be a post request or a put request, you'll be able to configure the body as well. Bunch of advanced options down here in terms of setting the protocol that you want to use from a network layer perspective, both for ping as well as for traceroute. And then also choice in terms of how frequently you want to be running this test. So by default, we'll run this test every minute, but you can configure this to be running slower or faster if you like. And so that's kind of the general overview of how you set up a test. Once you've set this test up, the way the data gets presented is sort of like this. So here we have a test that is running to ESPN.com. And what you're looking at is essentially 2 weeks worth of test results data here. And the timeline up top is showing you sort of points in time where there was some sort of latency or packet loss or jitter issue or something else going on. Everything that is green is a healthy sort of state of the test, and then everything that's orange is sort of exceeding certain thresholds. The cool thing about this is, given that we're doing a DNS lookup and setting up sort of ping and trace to the same host, not only can you see HTTP layer metrics in terms of overall latency, response time, connect time, domain lookup time, status code, as well as a certificate check, but you can also correlate all of that to the network layer, because we're giving you sort of network layer ping, latency, and jitter metrics as well. And so, when you identify one of these issues where you see, some sort of latency spike, first of all, you can disambiguate whether, it was an HTTP latency spike, but there was nothing going wrong with the network layer, like in this case here. But then you can dig further and say, if it happens to be a network issue, where was that network issue happening? And so the way you can do that is by looking at a visual trace route, like the one you're looking at here. So what's happening here is this particular agent is running a trace route to the destination that you've specified, which is basically a domain resolution of that ESPN.com domain to specific IP addresses. And we're doing a trace route to each of these IP addresses, each of the hosts that is serving up the ESPN.com domain. We're showing you the raw trace route output here, but then we're also showing you a visual representation of this raw trace route output, which basically indicates, all the hops that you're going through in order to get to that destination. Now, if these hops happen to be devices for which we're getting SNMP data as well, not only will we show you the synthetic metrics, it will also show you the specific device, the ingress and egress interface specifications, the CPU and memory utilization, as well as sort of the ASs that you're going through as you get from point A to point B. So that's just kind of a general overview of synthetics. You can do similar things with other test types as well. But the whole idea here is to be able to quickly show you problems and then get you to the sort of point of failure. With that, I'm going to pause there and give Evan the chance to show you how you can automate all this with Odyssey. So take it away, Evan.
So for this demo, we're going to cover 3 topics. For the first one, we're going to show how to deploy Odyssey into a Kubernetes cluster. The second, what we're going to do is look at, from an admin perspective, how to create a Kubernetes API level synthetic test. And then lastly, we'll look at, from a user perspective, how to create an application level test. So as I mentioned, Odyssey is open source, so you can follow along. We'll send links after this, but we're going to follow right along here. For this specific demo, I'm using, for the sake of time, I'm using 2 clusters. One is going to be local. This is just a local Kind cluster. If you're not familiar with that, Kind is a tool written by the Kubernetes community that allows you to run local Kubernetes clusters using Docker. So I just have Docker Desktop with Kind. To see the actual test results, we'll look at a Kubernetes cluster running in DigitalOcean. The reason I'm saying that is for Odyssey, there is no vendor specific or any requirements to run in a specific Kubernetes distribution or installation. It runs on any modern Kubernetes. So, okay, we'll get going. So the first thing we're going to do is we'll go ahead and create a namespace. And next, and this is basically just to keep all of the secrets and the pods and everything together. We'll now create a secret. I'm using just environment variables, so you'll want to obviously replace those with your portal email and your token. And then we give a pre-packaged manifest that you can use to deploy out to your cluster. Now you can download this and customize or use customize to change it however you want, but we wanted to make it an easy way to kind of get this rolling and get it deployed quickly. So if we look at pods, we should have these running. And if we take the logs, are now our operators running. Now this isn't too exciting just yet, but we wanted to show how easy it is to get it deployed. So what this operator again is, as I mentioned before, it is doing a watch on the Kubernetes API to watch for those custom resources, right? So we're ready to go. So going to the second example, I'm not going to wear the hat of a cluster admin, right? A Kubernetes operator, a human operator. So I'm going to look at creating a test specifically for the Kubernetes API. Now, the Kubernetes API, as you probably know, you've deployed it out, is kind of a very central component to a Kubernetes cluster. Everything uses it. So if there's negative performance or something happens to the API, it can have a domino effect on all kinds of services, such as a scheduler, recovery, and so on and so forth. So as an admin, I want to create a test, a synthetic check, to check the API to make sure everything's good, right? So if you're familiar or you are familiar using Kubernetes, it looks very similar to, say, a pod spec or any other type of spec. Here it's our custom resource. So we're going to create a synthetic task, we give it a name, and then here's our spec. And this is where we get into the specific Odyssey resource. Here we can define a Kentik company and site to help kind of group and organize your various checks in the portal. They'll show up there where you can filter on. And then we're going to do a simple HTTP GET here. So we're going to specify the service. If we take a look, by default, you get a service that is just the Kubernetes service inside a Kubernetes cluster. This allows you to query the Kubernetes API. So we're going to target that service. We're going to tell it to hit the healthz endpoint, which is just a built-in health check for the Kubernetes service on port 443 using a GET every 60 seconds with a timeout of 5. Since it is using TLS, we're going to turn that on, and it's self-signed, so we're going to say ignore the TLS errors. So if we just apply this, we see now we created the custom resource. So we can see we have our custom resource, and what it did, the operator took that and started reconciling, right? So it created an agent, created a test, and did all the things in the API. If we switch over here to look at our agents, we now have one of our synthetics agents, which has one test. And if we look at our tests, here is our HTTP test, just like we showed before. Now, the nice thing about this is you get all of the functionality and the power of synthetics here. So we get all of the checks to look to see what is my Kubernetes API responding like. We get the actual status codes as well as those network level details. And we can quickly drill into it. And if we happen to see like a spike here, we can start looking at what exactly was that, right? Now, this is nice because even though it didn't actually error out, we didn't get a 200, we can start seeing these trends. So if something happens at the same time every day, or we start noticing a slow progression, we can use the synthetics to proactively take action instead of waiting until that actually falls over. Okay, so now, lastly, let's put on the hat of an application owner. So typically a common pattern is to have resources allocated in groups and typically by namespace. So we're going to create a namespace here real quick. Typically, you probably already have this for you. But as this application owner, I'm going to deploy out a simple web app. If you're familiar with deployments, so it's pretty straightforward. I'm going to have a single replica using a container image on a network port. It's a web app, and it's going to have a service that allows me to connect to the pods. So deploy this out. It's pretty standard Kubernetes stuff. If I look at pods, and I can see I've got a service, right? Demo. Now, as an application owner, I want to have monitoring, but at the same time, for me to go and stand all of that stuff up, especially like a recurring synthetic type monitoring, would be quite a burden. So with Kentik Synthetics, we get this nice usability to be able to create these that I can monitor my own applications through very familiar tooling. So again, this looks very similar, right? I have a spec, I can put my company in site. One thing to notice here is there are no credentials, right? We've made a decision to have the credentials are managed at the cluster scope, whereas all of the tests and the agents are at the namespace scope. I'm also creating 3 tests here. So as an application owner, I want to know, is it up, right? Is it actually responding? Is it scheduled? Do I have any type of network connectivity to that thing? If that is good, then I want to do an actual HTTP GET to make sure that that is responding with the code that I expect, in this case, the 200. And then the trace allows me to see how that's actually traversing through the network. Now you'll notice there are no endpoints and IPs here. One feature that Odyssey does is it will reconcile and resolve whatever Kubernetes object you use to whatever the underlying endpoint is. In this case, I simply have to say, I'm going to use a service and I want that to be demo that I'm going to resolve this. At the same thing, or the same time, we can do the same thing with the HTTP GET. Use the service demo and specify the targets, right? So if I apply these out, I now can take a look at the pods. We'll see this one created the agent. Again, the agents are namespace scoped. So the benefit to that is that we took that design choice to make it, A, it's easier to deploy for application owners, but B, it reduces that failure scenario in Surface. So in the event that this agent happens to have a problem or die, it doesn't affect any of the others. All the tests are still running. So if I go quickly back and look at my agents, I can see there's my new demo agent. As well as if I look now at these tests, now I have application level tests, both for a ping, the fetch, and the trace. And if I look at these, I can quickly see just what does the health look like? Was there any packet loss? Was there any jitter? What are the, anything of that case at the network level? And then I can also drill in and see exactly also at the response times, again, even viewing down to the detail about, quickly see from an application level. So again, to summarize, easy to deploy. It allows cluster admins to monitor what they're targeting, right? Specifically, they're interested in is the health of the cluster itself. But it also gives a way for application owners to use and implement their own checks for their own application side. And with that, I'll pass it back to Anil.
Thank you, Evan. That was an amazing demo and live as well. Awesome. So just to recap what we talked about and showed you, we talked about how Kubernetes is great at enabling you to scale, but it does so by abstracting complexity. And so what that does is it basically makes your network as well as your infrastructure and applications less observable. And so by using tools like synthetic monitoring coupled with Kubernetes operator like Odyssey, you're able to now get the level of visibility that you had before using Kubernetes. But in addition to that, you're also getting all the flexibility and scalability that you get with Kubernetes. And so, if you're using Kubernetes today and you're looking for a way to monitor performance, this is definitely something that you should consider looking into. And so if you want to explore further, there's basically 2 things you can do. Number 1, you can go to our website at kentik.com. And if you hit that website, you'll see on the top right, there's a little button called Try Kentik. And if you hit that button and sign up for a trial, you'll basically get 30 days of access to the entire feature set that Kinetic offers, including everything that we showed you on the demos today. Of course, Odyssey is open source, so that's always free. But if you try that and you would like to learn more, we also have a virtual design clinic. And so the difference between a virtual design clinic and the webinar is that while a webinar is mostly one-way communication, a virtual design clinic is a very interactive session. So if you have questions after you try any of these things out, or just generally about Kentik, that's definitely something that you should look into getting into. Cool. With that, we just have one last question before we open it up to Q&A.
So thank you, Anil and Evan. That was a great presentation. So a few questions did come in via the chat. So let's open the Q&A panel now. So the first question is the Kubernetes operator open source?
Yes, 100% open source. And in fact, if you want to make contributions to it, I'm sure Evan and the labs team would appreciate that as well.
Great. So can we make contributions to the source code?
Absolutely, yes.
Great. Can synthetic agents be deployed in our own Kubernetes environment?
Yes, absolutely. So, regardless of whether you're running Kubernetes on-prem or within a cloud infrastructure or some combination of those two, you can deploy agents in all those locations.
Great. It looks like the last question is, how is synthetic testing priced?
Really straightforward. We only charge you when you actually run the tests. So there's absolutely no charge for installing agents. There's absolutely no charge for configuring tests. The only time we charge you is when you run a test. And typically, if you're running a test from a private agent, which is an agent that you host on your own infrastructure, we charge you 2.5 credits for every minute that the test is running. And then if you do the same thing from a global agent, we'll charge you 5 credits, and you get to control how frequently those run. So the less frequently you run them, the less credits you consume. And then the credits ultimately map to dollars.
Perfect. Awesome. So yeah, it looks like we've just about come up on time here. So we'd like to thank all of you for joining in today, and we've covered quite a bit of material. So this webinar was recorded, so you can review a replay of it on our website. So that's kentik.com. And please share it with your interested colleagues. So also in the next couple of days, you'll get an email from us so you can review the content, get a link to the recording, and get any other additional information you'd like. So if you have any further questions, please email us at webinars@kentik.com. And yeah, thank you again for joining, and we hope to see you all again soon.
Thank you, everyone.
Thanks.